Hello everyone, my name is Igwe Leonard and I'm a student of Covenant University, and I'm also in the scholarship program of David Oyedepo Foundation. So this is a community development project that was given to me as a means of giving back to the community as I'm in the scholarship. So this project entails me taking community students or students in my community and teaching them. Like the students I took specifically are students who want to get into the university. They need to write Jamb, so I decided to take them on a Jamb tutorial, something like that. And I didn't do it alone. I did it with some of my friends, like the videographer Igwe Dennis, and my able friend Oyekome Victor, who took chemistry, and I took physics. So I hope you enjoyed the video. Thank you very much. The scholarship project. I'm on a scholarship, so the scholarship entails that we do this particular assignment every session. So that we can actually touch a good number of places, we're going to be doing Jamb past questions. And normally Jamb past question is a very good tool or a very good instrument to prepare for any exam. They said, what is the force on a segment of wire? So what are we looking for? What is the force on a segment of wire? So we're looking for force, isn't it? And they said the wire is 0.5 meters long. That's what? Length. Length is what? 0.5 meters. And has a current of what? 2 amperes. So the current is 2 amperes. And they said this wire is placed in a magnetic field of 2 Tesla. A magnetic field of 2 Tesla. So what is the representation of magnetic field? B, isn't it? So it is 2 Tesla, right? In a magnetic field of 2 Tesla. Good. And it is at an angle of 30 degrees. So we just as if I'm having a magnetic field. This is the field. Yeah, you use lines to represent field, isn't it? So this is the field. And so the wire is placed in this magnetic field, and it has an angle of 30 degrees. It's inclined at an angle of 30 degrees. So let me just draw something. So this is my wire, and this is 30 degrees. So this is what you have. This is what you have here. So the force now from a particular rule, is it Fleming's left hand rule or Fleming's right hand rule that talks about the motion? The wire, how is it going to move? How is the wire going to move as it's in this particular field? How is it going to move in this field? How is it going to move? In what direction is it going to move? What direction? What tells us that? I think, who wants to help us? Is it the Fleming's left hand rule or the Fleming's right hand rule? So Fleming's left hand rule talks about the direction of motion. So using Fleming's left hand rule, we can get the direction of motion of this particular wire. So it's going to be in a perpendicular direction. It's going to be in a perpendicular direction, right? The magnetic field, the motion, and the current, they are mutually perpendicular. They are mutually perpendicular. Just as if I'm having something like this, mutually perpendicular. I said left or right, just right hand. Mutually perpendicular, something like this. Like if you have done vectors, if you are looking for the cross product of two vectors, the result you are getting is a mutually perpendicular vector to the 2 other vectors. So that's just how it is. So that's how this one is as well. So if I want to, the formula we use here is BIL sine theta. Sine theta, because we take the what? We take the vertical component. When we resolve the direction, we resolve it in the what? In the vertical direction. The point is, if you have a force like this that is inclined to the horizontal at a particular angle theta. If you have a force that is inclined to the horizontal at a particular angle what? Theta. This force here can be resolved into two directions, the horizontal direction and the what, and the vertical direction. And most of the time the horizontal direction is always associated with cos theta, and the vertical direction is always associated with what, sin theta. Most of the time cos theta, sin theta. But there is a clause: the angle must be to the what? It must be to the horizontal. It must be to the horizontal. That's just a cheat. Like there is, like, whenever the angle is inclined, there's a particular understanding that you can use to it, and you can get which one is it, cos or sin. But whenever you see that it is inclined, the force is inclined at an angle to the horizontal, it's the horizontal direction is always associated with cos, and the vertical is what, sin. Yeah. So if I want to resolve this force in horizontal direction, it's just going to be F cos theta, and if you want to resolve it in the vertical direction, it's going to be what, F sin theta. That's how it works. Yeah. So this sin theta here is as a result of this force, the force that is going to act on this particular wire is as a result of the force moving in which direction? Moving in the vertical direction, in the upward direction. So that's what's going on here. You get it? So that's how they came about sin theta. So now let's say this particular wire. Let's say this particular wire. If the wire was straight like this, what would be the angle between the magnetic field and the wire? If the wire was straight, what would be the angle between the magnetic field and the wire? Of course, 0 degrees. It is straight. It's not making any angle. 0 degrees, isn't it? You are placing, like, it's just as if I have something like this. This is the magnetic field is going like this. They are not intersecting at all. Is there going to be any angle? No. So the angle is what? 0 degrees. So that means, would that be a force? Let me answer that. Would that be a force on that wire? Why?
Sin 0 is 0.
Sin 0 is 0. Sin 0 is 0. There will be no force. Because sin 0 is what? 0. Sin 0 is 0. Now you need to know, if you are a science student, you need to have that one. Like, you need to know sin 0, 30, 45, 60, 90, 120, and so on and so forth. Like, if you know the acute angle, then you can be using there's some things that you can use to know the ones that are greater than 90. Do you get it? We call it the act. The act, yes, the quadrant theorem. I can use that. So if Jamb wants to be wicked, if they want to, like, first question, they don't want to be wicked. If they want to be easy on us, they'll just say, okay, they will give you all of this. They will not say the angle is what? 0 degrees. They will give you all of this. Do not put A, answer 0. That's the force. B, they will make you calculate all of this. They will put the answer there. Now, if you don't understand that when the angle between these two, or if the only thing you know was just BRL, because most of the time in textbooks it is always F equals to what? BRL. They do not include the sin theta, because most of the time the wire is always perpendicular to the magnetic field. It is not inclined. It is not majorly inclined. It's always perpendicular, because once it is perpendicular, sin 90 is what? 1. So what's the use of putting sin theta there? Because sin 90 is going to give you 1. So sin 90 times BRL is just like doing 1 times BRL. So they just put it as F equals to BRL rather than writing all of this. Do you get it? So you need to understand. So
okay, my name is Victor. Today I teach you I'm going to take you guys to things they are stored things. So I'm going to do the first question in chemistry 2023. So I'll just pick the question when, based on what the question talks about, I'll treat it for today. You understand? Let's start. The first question says, which of the following elements will exhibit the most electronegative character? Which of the following elements will exhibit the most electronegative character? A. Aluminium. B. Silicon. C. Phosphorus. D. Sulfur. Which of the following elements will exhibit the most electronegative character? A. Aluminium. B. Silicon. C. Phosphorus and sulfur. Can anyone answer? Yes. So of course, do you know what?
Yes, it has the highest number of electrons in the atom.
The answer is correct, yeah, but the reason. Okay, on the periodic table, let me just draw a simpler form of the periodic table. Let me just include the first 20 elements. So this will be hydrogen, and this will be lithium, uranium, boron, carbon, nitrogen, so this is how it's like the smaller one, or just the first 20 elements. So now this element here are called the group 1 elements. This one are called group 2 elements. This one group 3, 4, 5, 6, 7, 8, or 0. 8 or 0. Now there are some properties that used to change or vary maybe down the group and across the period. Now this one here is period 1, this one is period 2, this one is period 3, this one is period 4. So you can see how it is arranged: group, then period. Do we get it? So now electronegativity is like an ability of an atom in a molecule to attract shared pairs of electrons towards each other. That's what electronegativity is, like Ojukokoro or something. Let's say me and you say 100k on the floor now, and I give you 10k inside 100k. Understand? So me, I'm very electronegative because I have the ability to get more money. We are sharing the money, but I gave you the smaller part of the money, but me, I took the bigger part of the money because I have higher electronegativity. So on this, different elements have different electronegativity values. It was Pauling, I think that's his name. Pauling. It was the one that gave the electronegativity scale. He gave the different electronegativity values. So some elements are more electronegative than some. But on the periodic table, electronegativity increases across the period. So that's very, so just write electronegativity increases across the period, but decreases down the road. So I said electronegativity is like an Ojukokoro or something. You and I are supposed to share something, but because I'm more electronegative, I'll take the bigger part of what we are supposed to share. Understand? So if it increases across the period, so as you go from left to right like this, it will be increasing. It will be increasing like this. So this one will have higher electronegativity value than this one. This one will have higher than both of them. This one will have higher than all of them. This one will have higher, like that. So that's how it goes, be increasing. That means fluorine is very electronegative than all of these ones, right? That means neons will be higher than all of them, right? But no. Group 0 elements, they don't react at all. They are very unreactive. So they don't have any electronegativity value because they don't react. So how can they be electronegative? So this is where it stops. This group 7, they are the most electronegative elements in the periodic table. It should have been these guys, but these ones, they don't like to involve themselves with anybody. They are alone. So their electronegativity values are 0.